Hi Pre-Calc. Earlier in the first video, I was talking about function notation, f of x, and how it's read as f of x. And you know, why I was saying why, well, if we called everybody y, that would get very confusing, right? Remember I said if everybody in our class had the same name, everybody is Chris, 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 right? That'd get really confusing. So function notation allows us to give individual names to the functions, and the f of x format actually allows us to do shorthand. We can say what function we used, what we put in it, and what came out. So it's a very convenient and smart kind of notation. So what we're going to do now is we're going to evaluate a function, and I made a new f function and I made a g function. I'm going to sort of start with the f and then go to the g, but when you do your homework, you're going to notice when you do your homework that they're sort of back and forth depending on which function they're picking, okay? Alright, so this says f of 2, which means use the f function, not the g, the f, and in the f function let x equal to 2. I know this notation looks terribly weird, but that is what it's saying. Use the f function, in the f function let x be 2. So that's what I'm going to do. So therefore f of 2 is 11. f of 2 is 11. That's shorthand. That's the function I used, that's what I put in, that's what I got out. Now, if you notice here, they're not substituting a value for x. They're saying take the whole f function and add 7 to it. So if we look, the whole f function is 3x plus 5. That's what the f function is, 3x plus 5. And then I'm going to add 7 to it. So I'm going to get 3x plus 12. So that time I'm putting something after the function and not in the function. So be careful whether what you're doing is after the function or in the function. That's just saying take the whole original guy and add 7 to it. Make it 7 bigger. So we get that. Let me just write our f of x over here so I don't forget who he is. I'll call him Frank. Put Frank up here at the top of the page. Okay, now this one, again, you're leaving f of x as it is, but you're multiplying it by 3. I'm going to call him Frank or f depending on what I feel like here. So we're going to do 3 times Frank. So 3 times f. So it's going to be 3 times. You could use brackets or parentheses, it doesn't matter. I just like brackets sometimes for emphasis. So I'm going to do 3 times my f function. And I'm going to distribute the 3. And I'm going to get 9x plus 15. So 3 times f is 9x plus 15. Because you got to distribute the 3 to each term. Alright, this is where it starts to get weird and students start to be like, whoa, what the heck did you just do? Now, there's a little bit of a magic trick, but what you put into for x could be to change the name of x to somebody else. Like give it, like do you have a nickname, right? Are you always called by your name, or do some people call you other names, right? Do you sometimes change to a different name, right? So it's this kind of thing. So instead of saying f of x, we're going to let x equal to k. We're just going to rename x as k. So if we look at our function here, instead of it saying f of x, it's going to be f of k, which means that all the x's become k's. So it's going to become 3k plus 5, right? We're renaming what x is to be k. You know, and this can get beyond silly. I mean, I could change x to be a smiley face, right? I could change x to be a smiley face, and it would be 3 times the smiley face plus 5. It's really all about seeing the original function as a template that you can alter or rename segments, okay? All right, I'm still hanging out with the f function. Let me just rewrite him up here. Now, not only can you replace it with k, whatever you replace x with could be something huge. It can be huge. So now I'm letting where x was be k plus 7. So that means my x becomes k plus 7, and whatever I did to x, I now have to do to my new guts. It's like you're changing the guts of the thing. It used to be x, but you're like, okay, I'm going to make you k plus 7 and k plus 7. And now I have to distribute the 3. And then simplify it out. And I get that. All right, so that is changing the inside of the graph. If you make a stuffed pepper, you know, in the inside you could put rice, or you could put something else in there. I don't know what else people put inside a pepper, but I'm just saying you could sort of take the f function and stuff it with rice. You could take the f function and stuff it with tomato sauce. It's like you're just sort of changing what you're making the inside of, what you're putting in the inside. Okay, here again we're changing the inside. What used to be x, we're going to now let it be 3x. So what used to be, for some people it helps if you put a box where like the x's, they see that better. So if you think of the x's, it could be anything you want. Now I want it to be 3x. So it's 3 times 3x plus 5, which is going to simplify to 9x plus 5. Right? Weird, but that's the idea. Okay, let's hang out with the g function a little bit now. So same idea, but just a more sophisticated function. Hopefully I got you warmed up on that one, that this will go a little easier. So this is saying let x be 2. So everywhere in the function, now it's more than one spot. So this x becomes a 2, and this x becomes a 2, and then you got to simplify it. If it's a number, you can simplify it. If it's a variable, you can't. All right, so here we go. This is like the nickname again. We're replacing the x with a. Now, if it helps, think of everywhere there's an x as like a box, if that helps. So this x can be whatever you want. It's like a magic trick. So now x is a. And since it's a variable and not a number, I can't simplify it. The final answer will just be an expression. Okay, so if x becomes a, if we rename it, we give it a nickname, it looks like that. All right, let's try some more. Let me just write the original here. All right, now we're taking the g function and we're making it 3 times larger. So on the end, we're going to tag on 3. All right, so here we go. I'm going to take the g function. Oh, I could have just written it underneath. Okay, the g function is x squared minus 2x plus 10. And I'm going to add 3 to it. So it's going to end up being x squared minus 2x plus 13. All right, you're just making it 3 units larger. All right, here we go. We're doing a substitution. This says let x become 2x. So everywhere there's an x, you make it 2x. So let's try that. I'll make boxes because some people love boxes. So everywhere there's an x in here, put a box, and I'm letting it be 2x. Just like that. X becomes 2x. Let me just take off the boxes now. It's a little easier to simplify without the boxes. So 2x squared is 4x squared. Because 2x squared means you're doing 2x times 2x, so that's 4x squared. All right, and there's the answer to that guy. I just want to cover this briefly because some students get confused with graphing functions. And it's really just the same idea. I mean, even though it's got a fancy name, you can just replace it with y. Remember, it all used to be y before we gave it fancy names. So when you're graphing anything in terms of function notation, don't let the function notation knock you off. That is a fancy name for y. So then you can just go ahead and do it. So for us, we do the intercept method. So if we're finding the y-intercept, which is this guy, we're going to let x be 0. you know what, in this format, it's in y equals mx plus b. So you can just see that the y is 2, right? That's the y-intercept, so you can actually see it. All right, and the x-intercept, now we're going to let y equal to 0. So if y is equal to 0, you get 0 equals to negative 1/4 x plus 2. Some people hate the fraction, so I'll just kick that out right away. So 0 equals to negative x plus 8. Move the 8 to the, oh, let me just move the x to the other side, it's quicker. So x equals to 8. And now you've got it. Okay, and there's your line. So my big point was not so much graphing, because we did that in another lecture. My big point is that if it's in function notation, it's just a fancy y, and then you know how to do it from there. Wow, this video is long. The good news is that is it, my friends. We have finished 4.5. I hope you enjoyed it. I'll catch you. Bye-bye.